Thanks. Hello. I'm very happy to be able to today give you an insight on our MATLAB-based toolbox FMRelI, which is intended for the analysis of fMRI reliability. And here, of course, the first question is, why is reliability even important? If you have a look at publications with like the introduction of the research domain criteria, there was a real surge in interest in prediction and classification. But the biomarkers that we base these predictions and classifications on, they of course need to be reliable, otherwise you can't predict anything, and that's really a hard thing to do. Why? Well, we have a very small subset of very common paradigms for which we know the reliability, but this list is not really comprehensive. We have many different levels actually of analyses. We have many different coefficients that have been reported all over in different papers. And I want to really stress this point as it is key. We have historically had a focus of tasks to be optimized for stable and big main effects, which inevitably reduces or minimizes the between subject variability. And this is a real problem for prediction or for reliability on the individual level. And I can just demonstrate this shortly. As we are close to the lunch break, this is probably a good example here. Just imagine that you are hungry, you go out for a food cart, you want to get some food. And what you see here is a plot basically of different customers, a set of customers going to different food carts. And if we look at this plot, this distribution of the group preference, we would think that we could predict the individual choice of one person too. But the question here really is, would it be possible to get the same picture on the group level without any reliability on the individual level? And the answer is yes, we can. As we reframe it, for example, as a Galton board, now you see the different customers choosing food carts here. And we see there is actually no reliability on the individual level because this really lies within this individual level here as your choice on day one, for example, doesn't predict your choice on day two. So the first important conclusion here is that the congruence at the group level actually is not the same as reliability on the individual level. These two are different concepts. And as this is still a bit abstract, of course, we also tried to validate our toolbox on an actual data set that we had. We had a large-scale longitudinal imaging project. We scanned 126 adolescents there at 3 different time points at the age of 14, 16, and 18. And on each of these measurement sessions, they completed an intertemporal choice task. So this is a pretty easy task. They had basically a choice to make between an immediate reward that was lower or a higher reward that they could get after a certain delay here. And we looked at 2 different imaging contrasts. So the first one was the offer contrast. This was just the onset of the offer in this task. The second one was the subjective value contrast, which is just a parametric modulator of this offer contrast, which was based on the discount rate of each participant in this study. And the 2 first important points here, the discounting behavior was actually moderately reliable. And also, we found very stable main effects. On the left side, you see the offer contrast. On the right side, you see the subjective value contrast. Those both were very stable and big here. But if we now ask the question, well, what is a good biomarker? You could probably say, well, if we know the individual brain function, then we should be able to re-identify a subject. And in terms of, for example, here, global reliability, we had a look at the overlap too, so at the similarity measure here. You should have a very prominent diagonal because in the rows you have the subjects, in the diagonal you have the similarity of a subject with himself or herself. And for the offer contrast that you see here, that is true, that works. We also see it in the cumulative frequencies that are shown on the left bottom side. The blue line is the within subject similarity, the red line is the between subject similarity, and you want to have the blue line shifted to the right, as this shows a higher within subject similarity. Here this works. However, if we go over to the subjective value contrast, you see there's not really a clearly visible diagonal anymore. And we also had a lot of problems re-identifying subjects, shown by this black number on each matrix, which shows the number of re-identified subjects here. The same is true for the cumulative frequencies. If you have a look at that, the lines are virtually undistinguishable here. And this is a really striking outcome in the end. So we were very surprised because the behavior, as I said, was reliable actually. Now, of course, it could be that we just have kind of regional differences on a local level. So we also had a look at that. So this are voxel-wise reliability maps that you see here. We used the intra-class correlation coefficient. And if you once again have a look at the offer contrast on the left side, there are some regional differences here, but overall, if you look over the brain, most of the voxels are at least moderately reliable here. However, the subjective value contrast, once again, there are much less voxels that actually are reliable. And what was especially striking, when we had a look at common value tracking regions from other publications here, so the ventromedial prefrontal cortex and the ventral striatum is shown here in green, then the offer contrast had more reliable voxels in these common value tracking regions than the subjective value contrast that is intended for that, which is also a very striking result. Then we also saw, well, perhaps there is also some differences in networks. But as you see here, what I show here now is basically you group these ICCs over atlas regions and then get them into these U networks here. And you really see the difference lies within the contrasts, not on the level of the networks. On the upper panel, you see the offer contrast. There is some variability in the reliability, but it's not very big, and mostly the reliability over all networks is good. However, for the bottom panel, you see overall networks, the reliability is not good for the subjective value contrast. So, coming back to the original question, how reliable are brain responses that we measure with fMRI? We had this large longitudinal data set that we worked on here, and a very common reward task is often used. And our main takeaways here are actually we had congruent main effects in both contrasts, in the offer and the subjective value contrast, but while the offer contrast was at least moderately reliable, here the subjective value contrast really didn't actually get at the minimum level of reliability that you need. So, take-home message, you always have to really first prove that a biomarker that you have in mind is reliable in order to actually have a chance of making good predictions or classifications with it. So I have to, of course, thank a lot of people here, but I want to especially mention Juliane Fröner, who did most of the work on this toolbox and would have also presented it here today if she could have been here. And if you now have this kind of bad feeling crawling up your back, what is going on with my task? You should, of course, have a look at our preprint, which is up on bioRxiv here. You can also download the toolbox. It's freely available on our GitHub repository. You can fork it. You can also, of course, get own code into it. And if you want to have a deeper look into the toolbox, you can also visit me at poster 2537 and have a chat with me on the key features of that toolbox. Thank you.